So if you look at this particular file, record.h, which I just uploaded before I came here on GitHub. Okay, this is record.h is, just to let you know, is under CPP03 homework 2. So you can see that I just keep updating the file as we add more content, as we make more comments during the lecture. So what I try to do is any kind of important instructional point I made, I try to include it in the source code file right after the previous lecture. So here I just want to tell you there's a few things which are the critical point for us to understand what you're supposed to learn from doing homework assignment number 2. So I listed about 5 or 6 points included in the record.h, which you can download. Of course, the first thing you should learn is to learn one very basic standard template library called vector. STD column vector, about how to use them as we presented the example in the source code. And the second thing, which is important, this is the core of homework assignment number 2. Do you have a question back there? Any particular question? Yeah. What can I help you? Can you speak louder?
I've turned it up.
Okay, just passing by. If you have any question, I'll be happy to address that. But let's talk about this part, and we will address that part. Okay. All right. And the core of homework assignment number 2 is a design experiment. So this is high-level objective. This is how do you convert a story or some kind of description into objects. So by the way, this is called object-oriented model, at least as an example. You can think about that. We want to face a particular paragraph or a particular description of something. Well, how do we convert that description into a bunch of classes of objects? And then we can actually handle that piece of information in an object-oriented or programmable way. Okay, so that's what we want you to learn. So if you think about that, is just how to convert natural language into objects. So that's if you look at homework assignment number 2, I think I still have it here. We basically ask you to convert this part into a bunch of objects. And the thing is, at least the requirement of the homework is basically say you have to at least include those information in the red. All right. So obviously this doesn't have a definite answer. You can represent the whole thing using maybe one class, even though I think that's not necessarily the desirable option. And then you can decide, how many classes you want to have, and then use that. So there's a lot of what I call a trade-off about how you will make this choice about designing a bunch of class or to realize the idea. So in homework assignment number 2, CPP03, I provide you one, I call the reference implementation about, okay, this is one way to do it, but it might not be the best way. You're welcome to come out with whatever way that you think is you like to do that. And you should try your design and try to run. The key thing is that you will be able to represent those key information in the red that in that description given by the homework to a bunch of class that you're going to print it with. So that is the number 2 object. By the way, when I'm reading this, this is going to be really, really helpful for you to, how do I say that, to get an idea about what kind of question you're going to see on next Friday for the second midterm. Okay, so second midterm is essentially all the instructional objectives of homework 2 plus operator overloading. Okay, that's the content. And as I mentioned to some of you, that whatever appear in the Monday lecture, the coming Monday lecture, everything up to that point is actually going to be the range that I'm going to ask in the second midterm on Friday. Okay, yeah.
So like based on the beginning of like we are like basically like if that's like an input, you're like
Oh, sorry, give me 1 second. What's your name? I forgot your name. Yeah. Brandon, okay. Brandon actually reminded me that I actually made the mistake when I talk about the second midterm. Sorry, just 1 second. So it's going to be everything I put here in the homework 2, plus the operator overloading, plus the reference, the call by reference, call by value. That's why I feel your question is very valuable, because and the example I use is object reference.cpp is actually under CPP 01. So if you go to CPP 01, I believe, I should put it somewhere else, but you can see that here you have an object reference. This is the file. Make it bigger. If you remember, we spent quite a bit of time talking about this file, object reference, talk about this item ecs36b, talk about set quantity by value, set quantity by reference, set quantity by pointer. And basically this program will be part of the second midterm next Friday. Okay, now go back to your question. Sorry about that. What's your name?
Oh yeah.
Sorry to interrupt you. Go ahead. Sure.
Like so like this entire like paragraph is like an input and like you have to like convert those red parts into like an object.
Yeah, except is conceptual input. I didn't ask you to do like a natural language processing like a GPT. So eventually somebody can actually, hey, by the way, this is a great way to do that. You enter this section of text into GPT and ask them to say, hey, can you produce a bunch of classes for that? I don't think GPT today has the exact capability, but I'm pretty sure the generative AI will be able to handle this kind of task. So meaning that you enter a question. So right now what I'm asking you is, when you say input, I assume it's just conceptual input to your brain. And then based on your understanding about this task, you produce a bunch of classes. Does that clarify?
Yeah, and also what's it hard to just like make file and that dump into the JSON?
Yes, if you look at my instructional objectives, you can see that number 3 is actually talk about makefile. And number 4 and number 4.5 is about the dump facility, about dump to JSON facility. So I'm going to teach that today to talk about both topics. And I'm not sure, I'm not really positive because this is a big topic. So by Monday, at the end of the Monday lecture, the coming Monday, I will be able to finish. So whatever I finish is going to be an exam. Whatever I cannot finish, I will continue and push that content maybe to next exam. Okay, good. All right, so just want to clarify, because that's what I intend for you to learn. For you to think about, okay, how do I, if you think about that, I give you a piece of text, you can start to produce a bunch of class from scratch. And that capability is important. But alternatively, what you can do also is that you can try to reuse some of the class that's already been defined by somebody else, such as I provide a bunch of class within the CPP03, which is the homework 2, and I call that a reference implementation, and then you can reuse that. For example, if you compare CPP03 and CPP01, they essentially define the same kind of GPS location, things, and person, but if you compare the code, it's already dramatically different because I enhance so I can actually support my version of the record better. Okay, so you can see that object-oriented programming is sometimes from scratch, but sometimes it's really pick up something is already semi-complete. And then you basically use that as a basis and start to extend it and try to change it such that it will work for your application. Okay, so this is the capability. In fact, I think this is one of the most important capability for object-oriented programming, is that you can really model a problem and then get it to work. Okay, so that's what we want you to learn. Okay, so okay, just a little bit about second midterm. So here is what do I mean by trade-off? The trade-off usually says, okay, I have 2 pieces of code, and this 2 pieces of code, I can both accomplish my purpose. And then I want to see which one is better and why. So that is a trade-off. So let me give you an example. This is the original example for GPS. So you can see here, over here, it has GPS location, right? It has Wednesday, October 4th, and ended in the room 1010 of TLC, Teaching and Learning Complex, right? You can have a location looks like this. How do you do extension? How do you actually make a GPS location, which is the current design, has only two numbers represent the latitude and longitude, but you want to have somehow to represent maybe the name of the location, right? The name of the location. So there are multiple ways you can do that. So one of the ways you can do that, if you look at what I did in this directory, which I already changed it, I basically assume adding one attribute. I just adding one attribute, and that attribute is called location label, which is a string. So then I can actually use that to store the information about the label. And so when I represent that natural language description, I can easily do that. Okay, so this is one extension I made with GPS to help us to handle that. But there was another possibility. Let me actually tell you, this is another possibility. I actually implement another class called busstop.h. And what is busstop.h? Is using some mechanism called inheritance, which I haven't started talking about inheritance, but this is the simplest way of doing inheritance. So I made the bus stop, which is inherit from GPS DD. And then inside here, I have the name of the location label. So essentially, I push the label to design to the subclass, which is called bus stop. So I can push the name of the bus stop name. And then I can actually represent the same kind of information. So you can see there's 2 different ways of representing the information. And the problem with this particular trade-off, which I don't like this design, because this means that I can only represent in the record as a bus stop. I can no longer represent just other locations such as TLC. I can only represent the bus stop, which is not as general. So you can see that there is some kind of qualitative debate we need to make in terms of how to design a different thing. Okay. All right, the next two topic I would like to talk about, which I will talk about today, is about separate compilation. And also, I thought I want to talk about what do I mean by some of the minus I flag. And oh yeah, number 5 is also talk about installation related to I send out the announcement, but also about makefile is about the minus I flag and minus L flag. Those two flags are somewhat, you as a programmer, you need to know that those flags define how your environment, which means that you're running a Mac or you're running on a WSL or Ubuntu machine, that your minus L flag and minus I flag might be set differently. Okay, that is another topic I would like to cover. But this I will consider is not necessarily the core topic for homework 2. So I put it the last topic to talk about. Okay, so this is what 5 or 6 different kind of instructional objectives I hope you will learn through the process of homework 2. All right. Any questions before I resume from last week? Yes, you have a question? Okay, don't worry. Somebody just... Yes, please.
Going back, is the inheritance basically just like a header file, but it already has a lot of written out?
Yes, inheritance is a way to reusing a class that has been defined before. So essentially, I include all the things that's already defined. In that case, in GPS, bus stop inheriting from GPS class. But in the child class, which is the usually inheritance relationship as a parent class and the child class. And the child class or derived class, you can provide whatever extension you want to have. So I just want to say inheritance is a big topic. And I will spend lots of time talking about that. But right now, I just give you the most simple form of the single inheritance for you to, yeah. So I know some of you are Java programmer and you probably already know a lot of inheritance. You will have some kind of advantage in learning this process, but I do want to tell you that there are certain parts of C++ inheritance. It's dramatically different from Java, especially in terms of their detailed implementation. So we will address that. I mean, inheritance could be a really much more complicated topic in C++ than Java or other object-oriented programming language. Guess what? It's all because they have something called pointer. Okay. All right. Any other question? Yes.
Sorry, give a quick review of what protected classes.
Okay, protected class, until now, don't worry about that. It's related to inheritance. I'm just always editing, okay, because I know I eventually have, but you can see that the way I wrote it, protected class is nothing. There is nothing on the protected, but protected is just for inheritance. Okay, Brendan, so you have a question about reference you would like to, I can address very quickly? Passing by pointer versus what? Okay. Good question. So Brendan was asking, what's the difference between passing by pointer and passing by reference? So let me give you a 10-second answer. They're exactly the same. They're exactly doing the same. Last time, if you watched the video, I show you that the address, the memory address they're doing is exactly the same. So then what's the difference? It's just syntactically. They try to represent exactly the same thing using two different linguistic structures. You can see they're even very similar. Let me finish what I'm saying and I'll answer the other question. But historically, why we have two different ways, very similar, so they're doing the same thing. call by pointer or passing by pointer is the original C style of function call, where call by reference is more modern, developed with C++. That's why we have two, but they're exactly the same. Yes. Okay. They're doing the same, but the compiler will treat it as the same. The compiler will not treat the pointer the same as the reference. Unfortunately, G++ compiler. So I would say, okay, that is a very good question, but it's a controversial question. So because C++ and C, they are basically backward compatible. So you can certainly use pass by pointer, no problem. But I will recommend if you have a group of programmer, they're mostly handling C++ programming, you should use call by reference as much as you can. Okay, and the reason I'm saying that is a lot of C++ programmer they're not familiar with call by passing by pointer. I would say that, yeah. Answer your question. That's an excellent question. I would say the decision is actually by your project team. Whatever you decide, what's the best way to do. In C++, I see most people use reference in that case. Okay, but just let you know, passing by reference, you can, if you really want to do that, after you pass the reference, you can always easily convert that to pointer by just add an and sign to see the address. Okay, so they're really interchangeable, but in the interface, maybe passing by reference is more popular, I would say. Okay, any other question? They're the same. Pass by reference, pass by pointer, they're the same. Because compiler, when they do code optimization, they basically convert it to exactly the same code. Good point. All right. Okay, so let's start to look at this. Let me go back to the question number 2 about design the story. Okay, I want to show you the first of the 4 events that I would like to produce. So let me just go back to the event again. Look at this text. So there are some explicit and implicit event we need to worry about. So let's try to look at the first event. The first event is saying that Wednesday, October 4th, 2023, around 4 p.m. in this room, right? In this room. So it basically say, hey, we're giving a lecture. So that's explicit about a location over here. But then it says the instructor took the L line. So the instructor in this case is Felix. Let's assume it is Felix. Okay, unless you guys file me, so it will change the instructor. So implicitly, this is how you need to process, or whatever ChatGPT need to process, is that this indicate that the instructor was one of the person in that room in the first event. So the first event, even though it says nothing about who's there, but in this description, you know the instructor is there. Okay, the second thing is that there is another student ecs36b student, John. So John will be another person over there as well. Okay, so that's why sometimes to convert that to the object is a hard task. Because not only you have to worry about the format, you have to worry about the implicit relationship around this event. So essentially, you have at least 2 persons you need to include. One is instructor, one is John. They're both being implied in the first event. Okay, so that's the people involved. And the second thing is things. In this description, it says that I have 2 things. One is the Android phone, and one is a JLab earplug. So these 2 So now the relationship is that, well, those two belong to, okay, first, whenever you have a thing, it usually has an ownership. So who actually owns those devices? Apparently, in the description later, you will see that, okay, this belongs to the instructor. But then the question is, where are the events? Where are the events? Where were the events? Sorry, where were the device? Sorry, this is Friday. I feel my speech capability degrade by 20%. Okay, so you have to correct that. You guys are much younger than me. So the device, those two devices, where were those when the first event took place? I mean, you can actually assume, okay, Professor Wu actually left his phone in his office about 10 minutes away, and then he retrieved that after the lecture, which is obviously not likely because the class finished at 4. He need to get on the bus at 4:10, right? So 10 minutes is not enough for them to retrieve. So in some sense, if you interpret this, also imply those two devices are actually already with the instructor during the first event. So okay, that process is called our cognitive capability about understanding what's happened. And then we understand, okay, now we know there are two people. One is the instructor, the student John, and then there is two devices is already in the first event. Okay, if that's the case, let's look at the programming. So, by the way, the programming already updated. You can actually check it. Let's go to. Okay. Very quickly, I actually update GPS. So now the GPS include the label. So the first label is Costco. The second label is TLC. The third label is IKEA. Okay. And I create 2-person, Felix and John. I assume Felix live in the Home Woodland. So Home Woodland means Costco, means Felix live on Costco. And so next time, if you want office hour during the weekend, just go to Costco, okay? Just let you know that. Or after, whatever time. All right, and then the other student, John, he lives in IKEA, Sacramento. If you want to have some coffee with him, drive to West Sacramento. Okay, so we have 2-person, Felix and John, and then with location. And I don't want to talk about Swedish meatball. That's okay. Here is the event. So I create the time. So the way JV time work is that you just input the string in this format, which is 2023 October 4th, and then whatever time format, 4 o'clock, 16:000. And then I create this event called homework 2 R1. This is the first record or first event. And take a look at this. I create a bunch of things. I create the Android Felix, and this is just create a thing object, which is the Android phone. And then I actually create, but one thing is I associate ownership. So when I could have the constructor, I would say this phone, the owner is the person Felix. And then I have the JLab, which is the owner is also Felix. Okay, this part is this 6 lines are really the line I actually construct the, what do I call the event itself, or record itself. You can see that. Let's look at the 6th line. The first line, I just add a person. The first 2 lines is just adding 2-person. The next 2 lines is I adding this 2 device. And then I set the location of this event, and I set the time of this event. So now with this 6th line, I essentially finish the content about this record number 1. All right. So in fact, I'm done already. I'm done. I already created this event, and I need all the people who read this code to trust that this information has been stored correctly. Obviously, you guys don't trust me, right? So I have to show it to you. So what should I do? I actually have this function called dump to JSON. So In almost all object-oriented language, when people design a class, they always have a way to provide a dump about the object. So what do I mean by dump of the object? So today I give you an object, that this object contains a lot of attributes. I mean, how do you know what's the information included in the dump? Sorry, included in the object. What you need to do, typically you go to the .h file. You go to the .h file to look at, for example, person.h, you have to go to person.h, and then you have to look at all the information being included in the class, and then you have to decide what member function, or you can use stop operation to retrieve the value, right? So which means that it creates a lot of workload for the programmer who try to do debugging, who try to understand the object. So instead of try to have the programmer to do that, usually you'll create a function called dump. When you call dump, it automatically prints out all the attributes that's actually supposed to be readable from the object. So you can see that that's just a facility for you to quickly understand the object you just created. Okay. But the difference things here is that I actually create a function called dump to JSON instead of dump. So first I want to tell you what's the difference between dump and dump to JSON. So typically dump is just print out to standard output or standard error. So essentially it just print out the information, and it's okay for if you have a 1 or 2 object, you want to dump it and then you want to read it. But the thing is that it's better to have a different format, a standard format, to represent information, particularly to the object. And then we can use that format to be able to convert the information within the object to that format. In fact, this is a much more powerful than just print it out, because later you can use that standard format to use this object to do a lot of things, which we will teach you in about 2 or 3 weeks. So let me go back to the instructional note here. So what is JSON? So this is instructional number 4. So what I write it down here is called a linearized representation of object. Okay, so number 1, if you read if I say representation of the objects, you say, okay, you represent an object some way, okay? I take that. But what do I mean? What do I mean linearized representation? I mean, what does that word linearized occur to you? What do you think I try to convey over here? Maybe it's Friday. I didn't mean that. Okay. Yes.
Like they're in a specific folder.
Maybe there's a specific folder. Yes. Okay. Any other guess? I mean, both of you actually hit some point, not exactly. Yeah. One for example. Yeah, that's also important. Okay. So I think you guys are all hitting the good direction. In fact, you say something better than what I intended to tell you about linearization. So linearization really means that, what do you think as an object? This is an object, right? This is an object. What's the shape of the object? It's not a line, right? It's not a line. Linearized means I want to make it a line. If I give you a 2-dimensional array, can you represent that with a line, with a linear? I can, right? You can actually, later I will teach you how to represent any representation using a line. But essentially, this is not a line, not a one dimension. Okay, linear means one dimension. How do I make a multiple dimension, a complex object into a one dimension representation of the information? Why is it important? Because computer, we really need to eventually convert everything to one dimension, to a line, like a string. Because if I cannot do that, then how do I transfer the information from one point in the internet to the other? If you think about that, when I transfer information from one point to the other, I always have to convert that information to a sequence of characters or bytes. And then they can convert it back to whatever format, regardless is a text, video, or whatever information you would like to represent. Okay, so that's called linearization about the information. So essentially what we're saying is you have an object, this object is called record, and the record has a bunch of person, it's a vector of person and a vector of things. And it has a timestamp, and it has location, and it has all kinds of information with different data type. And how do I actually convert that to a linear format? So I know, okay, my object is like this. And that's what JSON provides. So JSON is a linear representation of your object. And in fact, I just want to tell you how many minutes do I have? I have 4 minutes. Okay, that's great. So, I mean, for example, today, this is obviously very doable, very desirable. I have a Python object, and I convert it to JSON. I convert it to linear. And then I send it to the other end to a C++ program, and the C++ program convert that linear to C++ object. What does that mean? It means that my JSON object becomes a C++ object. So I break the barrier between object-oriented language, and then I can represent the same object via this intermediate representation called JSON. Okay, so it's really critical representation. So when you think about this, this is a way for why JSON is so popular, because it can represent all the objects in a string format. That's what they're doing. Okay, so let me first show you, because I only have 3 minutes, I'm going to show you the result of the code. I was talking about the representation. So look at what I did. I actually create this object HW2R1, and then I have called this dump to JSON, means that I'm actually producing a linear representation of the whole object of the record one. And then you see that I just basically print it out as a string. Okay, I printed out the string using the standard CL. So let's look at the result. I forgot to make. Okay, I basically produce, but look at how I represent. Okay, the event actually starting from here. Starting from here, you can see that this is actually a linear representation of a character from here. And at the highest level, I have a 4-parameter what, when, where, and who. And let's look at when. When is just the time for that string. But look at where. If you look at this, where is what? Latitude, this number, local label is teaching learning complex, and longitude is equal to that number, right? So let's just look at this part. What did you see from here is where is an attribute at the class record. But inside that where is pointing to an object of GPS. And inside this pair of curly bracket I highlight here, it print out 3 attribute which belong to the GPS.h. So just looking at this 6 lines of code I highlighted here is actually represent information about an object that's contained another object. So the higher level object is what? A record class. But the one level lower is GPS. And that representation actually combines these two together as its content. Okay, so let me tell you the notation. Everything in JSON is very simple, is what we call key value pair. So key value pair. So for example, the key always at the left-hand side of the column. So in this case, the key is latitude. So key always represent your attribute. And the right-hand side is a value, which means that that key is represent what? So the value is type. If it's a double, it's double. It's a string, you have to do double quote. But how about this key value pair? If this key value pair, the key is where and the column, and what is the right-hand side of the column, you see a pair of curly bracket. So in JSON, a pair of curly bracket always indicate an object. So essentially, this representation is saying that the key, the attribute name is where, but on the right-hand side is not a basic type, it's an object type. And the object type is basically included, that object is included whatever that pair of curly bracket try to give you. So that's how you can actually represent an object within another object. So let's take a look at the other one. The other notation is this bracket. Sorry, give me just 1 minute. So this bracket is array. So essentially in JSON, everything has to be this 3 things. One is basic type as a value. The second type is object, which is curly bracket. The third type is array. When you have an array, you use bracket. That's it. By the way, that's the whole thing you need to learn about JSON. Key value pair, basic type, object type, array type. That's it. And then you can see that inside this array, I have 2 objects. You see that there is another 2 pair of curly bracket. The first curly bracket represents the first person Felix. Okay, and the second curly bracket represents the second person John. So by doing this, I kind of linearize a complex object such as a record into just character by this JSON format. Okay, so I hope this is the first JSON that you have seen today, and hopefully you will learn something from here. Have a good weekend. See you on Monday.